Test, test. There we go. Now I can hear myself. So good morning, everybody. Thank you for having me here at the inaugural Code Blue. I was inspired by sort of the statements that were made in the media about the purpose of Code Blue, and I've worked that into my keynote. And so what it's really done for me is made me think a little bit more about an analogy between public safety and network security. And we're going to explore that a little bit in my talk. And we're also going to talk about some other trends, big trends happening in the industry. So I'm not going to get very technical, but what I want to leave you with are some bigger ideas and concepts. And then I hope to talk to you about them today and tomorrow. So how did we get to where we are today? Without going too far back, we can start in the agrarian period. Things were really simple back then. Everybody was a generalist. And then we moved to an industrialization phase, which was a lot of simple repetition using machinery. Also, unskilled labor, generally. You needed skill to set up the machines, but you generally didn't need skill to run the machines. And then we moved into an information age. And you can see the trajectory. We're specializing. We're getting more complicated. Worker skills and education become more important. Systems are becoming more interconnected and more dependent on each other. So the big trend is specialization. There's not many generalists left in the information security area. People specialize if they want to stand out in the crowd. You need to be an expert if you want to advance your career. What are you an expert in? Static code review, dynamic code review, JavaScript, reverse engineering, deobfuscation. You can specialize in so many things now, where 20 years ago, that was not the case. This is the world we live in. The side effect is complexity. The economy naturally becomes more complex the more people specialize. And it gets to the point where no one person or small group of people can actually understand what's going on. It's greater than any one of us to conceive of in our mind. So that's where we are. We're moving to a more complex environment. And you can see this in our networks. Here's an original drawing in 1969 of the very first ARPA network. It had one node. That was September. But you can see, December, it already has 4 nodes. So in a couple of months, it's grown 4-fold. By 1975, the ARPA network is on both coasts of the United States, and there's even microwave links off to London and Hawaii. So I think we could still keep this in our head. I think if you were a system administrator, you could understand this whole graphic and have a good understanding of what's going on in the network. But by 1977, here's a logical diagram. It's gotten too complicated to really put on a map right now. Now you probably can't keep it all in your head. And I dare you to keep that in your head. So this is an attempt by Chris Harrison to show the size of the interconnects between countries carrying internet traffic. So the brighter, the more dense the traffic. And I have a map from 2007, and I have this from 2011. And you can see the map is turning into a big pile of white. So things are, in the language of the World Economic Forum, this is a hyper-connected world. There's too many connections for you to completely do any kind of link analysis. And it's forcing us to look at the internet in new ways. Here's Google trying to give us a new map, a map showing popularity or traffic statistics. And you can sort of see there's a universe here. And only a few of the largest sites are standing out. But you can zoom and zoom and zoom. It's a fun site to explore. You quickly realize how insignificant your own site is compared to everybody else. Now, if you go back 110 years, oh wait, I took that slide out. So if that's the environment we're operating in, the actors, the bad actors, the good actors, the companies operate in, I'm going to just quickly go through 4 groups. So when we're talking, we have a common understanding. And when I'm trying to explain to decision makers, and when I use the term decision makers, I mean maybe politicians, I mean maybe executives, people who are purchasing things, people who are setting policies. I say nation states generally want secrets. And the reason for this is generally nation states want to make sure you're not lying to them. So when the United States says, yes, we do covert action, the technical term is covert action, what we're really trying to do is verify, is the United States sure that what North Korea is telling them really what North Korea is doing? Is what Iran is telling us publicly really what they're doing behind the scenes? Right? So we're trying to verify what people are saying, generally through nation states trying to find out secrets. Criminals don't care about secrets, right? They're hard to monetize. Who do you sell them to? Generally, organized criminals want things that are very fungible, things they can sell quickly, credit card numbers, bank accounts, wire transfer information, databases. Nation states have printing presses. They can print money. They don't need to steal what organized criminals are stealing. And generally, protesters want attention. And I'm using the term protesters a little lightly, but a protester might be a group like Anonymous. It might be a group like Greenpeace that's trying to draw attention to a cause like whaling or oil drilling. It might be a political protester opposed to a certain new policy. But generally, they'll do things like denial of service attacks, deface websites. What they're trying to do is draw attention to their cause. And finally, we've got hackers and security researchers, academics. And they generally want knowledge. They want to understand, how does the network work? What's really going on? And that's you guys in this room. At least I hope it's us, right? I mean, we're here to try to understand what's really going on. What are the risks? What can I do with the network? Can I make the technology do things it was never intended to do? Can I build a new product based on something, an old idea? So these are the actors. Now, the interesting thing is only hackers and security researchers generally discover new classes of vulnerabilities. We expose poor product security, and we spur public debate. So if you think of it, we're sort of like a white blood cell. We're like an antibody floating around in the internet, identifying problems and exposing them to the world. And then we hope things improve. So if we were not providing this function, if government regulated what security researchers could talk about, if governments regulated what academic security people could publish, the public would be losing the one voice where they can learn what's really going on. You know, what product do you buy? Do you think Microsoft is going to be honest with you? Or do you trust the security researchers that have been studying Microsoft security? So this fourth group, I feel, is critical for public debate. The interesting thing is, criminals and governments don't do this. It's not in their interest. Why would criminals tell you how they're breaking into the site? Why would a government go out of their way to point out how poor their regulation is or the standards aren't being met? So if you think about all the actors on the internet, all four of them right now, their interests are somewhat aligned. You can't steal money on the internet if the network is down. You can't break into a country and look at their secrets if the network is down. Right. Everybody needs the network to work. And so for the last 2 years, I've been asking audiences, think about this. Is there a fifth group? Is there a fifth group that does not need the network to work? I'm really curious. I can't really think of a group that would not want the network to function. But if you look at the amount of problems we're having on the internet today, and that's when everybody needs it to work, it makes me very nervous that if a group doesn't need it to work, we're really in for some trouble. So this is my Jeff Moss invented graphic. Kind of made this up. And so what I did is I would ask people, what's the largest denial of service flow you've seen? And then I would chart it. And my thinking is, that's how big the attack is that you'd need to be able to absorb if you want to stay online. I did this when I was working at ICANN, and I was really concerned about denial of service attacks against the root servers of the internet. But it's applicable not just to the root servers, it's applicable to your company. You know, if in 2012 you could absorb 200 gigabits of attack, you were fine. But now it's February in 2014. You're not fine. You can't absorb that anymore if you can only absorb 200 gigs. So if you look at the trajectory, is sort of the health of our networks improving or not? The direction's not good. So just recently, the largest known denial of service attack was a DNS reflective amplification attack against Spamhaus. That was last year. It was about 309 gigabits. If you see this red line at the bottom in the red dots, that should be at the 100 gigabit line. It's moved up when I resized the graphic. But anyway, at 100 gigabits, that's the fastest switch port you can buy right now. You completely saturate a switch port with more than 100 gigs of traffic. If that's all you've got in your colo center or your internet exchange, you're done. So the only way you're going to absorb more than 100 is you have to have more switch ports. Just last week, the new largest attack was made, over 400 gigabits against Cloudflare, using reflective amplification attacks using the network time service. So how are we going to deal with these problems? Well, we can look to the investment. People, when you invest, they do things, they specialize their money to get larger returns. They take more risk, but you can get more returns. This example would be, put all of your money in Apple. And if Apple goes from $500 to $1,000, you just doubled your money. But the problem is, if Apple goes down to 250, you're screwed. So now what we do is we diversify. We reduce our returns. We only own 10% Apple. But now if Apple goes down, we've limited our exposure. We get less return, but we take less risks. And if you look in the future, where are we leading? What kind of problems will we be facing? I'm saying they're going to be complexity-related issues. And I say this because we're moving to the cloud. And we even not just have clouds, we have virtualized clouds and clouds. And that leads us to the problem that failure modes in complex systems are impossible to predict. Just like I said earlier, the networks are too large for any one group of people to fully understand the network. Failure modes now are too complex for anybody to understand. Systems will fail, and we may never understand why. And you know what? That might be okay. We might be able to adapt. We might be able to work around. We might be able to mitigate. We may never understand the root cause. Here's an example. These are cameras used to read license plate numbers for traffic control and for parking. Fairly straightforward. It reads a license plate number and decides if you're speeding and to give you a ticket or not. But what do you think can go wrong with this? What's wrong with this picture? Look at that license plate. It's a little SQL injection license plate. And you can see by the reader board on the right, they're starting to drop data out of tables. I don't think the network designers, the database designers, thought of people doing that to the front of their car. In the United States, there's a lot of license plate readers on police cars, and the most popular license plate number is XXXXXX, because that's what a chain link fence looks like to a camera reader. So I really like what the Code Blue press release had to say. And I'm going to focus on this last little part. We named the conference after the code because we hope to save the world by combining people's knowledge. And I think really this is the only way we're going to move forward. Groups of communities working loosely together toward the same ends. It's too large for all of us to coordinate, but we all have similar interests. We all want the network to function. So what we're going to have to do is orient ourselves and move in a loosely coupled direction toward improving network health. And I really like this public health analogy because it allows us to have a new conversation with decision makers. Like, no doctor thinks they're going to cure cancer. If you go into medicine and you say, I'm going to cure cancer, people are going to laugh at you. We understand cancer is too complicated. There's too many causes. It's not healthy to tell yourself you're going to cure cancer. You're going to be disappointed. And we don't necessarily cure diseases anymore. We manage diseases. We mitigate them. We reduce their effects down to such a low percentage of the population that diseases are no longer life-threatening. Sounds like what we need to do with risks on the internet. And it's also possible to be reinfected. I mean, how many people have patched their system just to find out the new patch is vulnerable to a previous exploit? This is just the way things work in the medical field. So I think the analogies line up really well. Not perfect, but it allows us to now have a conversation with a new group of people that maybe they don't understand firewalls, but maybe they understand cancer. This might be a good way to talk to politicians and decision makers. I think it's really healthy. And I'm going to go into that for a little bit. Here's the old way of thinking, right? Perimeter defense. You've got high walls, you've got a big moat. Perimeter defense. And when you talked about perimeter defense, you generally talk to your security department and your IT department. And maybe you talk to your application teams to let them understand what kind of a network environment they're in. So the problem is out there, it's at the border, and you're dealing with a small number of teams. And if something goes wrong, it's sort of a disaster for the patient or the company. Nope, what happened to my... The new way of thinking is the Trojan Horse. They're already inside our network. You have to assume the bad guys are inside your network. You're already compromised. Okay, now what are you going to do about it? You might have already been exposed to that disease. You might have already been around a carrier of a cold. What are you going to do about it? Well, now we get to have a much more healthy discussion. Now we have to talk to our legal department. What are we going to do if we get compromised? Are we going to call the police? Are we going to sue the people who have attacked us? Are we going to try to enforce contracts? What are we going to tell the world? We need to get our communications department involved. Are we going to tell the world what happened to us? Are we going to pretend it didn't happen? Risk management. What do we need to protect now? Because they're inside. And if they're inside and we can't protect everything, we need to decide what we're going to protect. We need to involve finance, because there's a limited amount of money we can involve protecting ourselves, so on and so forth. So you can see, what would you rather have? A company that has had this kind of a discussion involving all these departments? Or would you rather work at a company that's only had this kind of a discussion. If I was leading the security team of a company, I would want to work here. This is where I could have the most impact and where the company has the greatest chance of having good health. So it's 2014. You still can't send email securely today. You can't have a secure phone conversation today. It's essentially impossible to browse the web. And name resolution is essentially insecure. It's getting better with Dnsec, but it's essentially insecure. Why is this? This is the way it's been for 20 years. 15, 20 years. As a community, why can't we move forward? Think about all the technology and the billions and tens and hundreds of billions of dollars that we've spent on networks, mobile phones, gaming platforms, medical systems. We've invented whole industries. Still can't send email securely. Still can't have a secure phone call. What's going on? So when people used to ask me this question, I had a nice answer for them. And it went something like this. In the 1990s, we thought that consumer selection would be the solution. The market forces would drive people toward better products. How many people here remember the advertisements? If you want a safe car, you buy a Volvo. Right? Everybody knows that. You buy a Volvo. Somehow Volvo convinced us that you need to buy their product if you want to be safe. The problem is consumer selection doesn't work. Buying a product on security features is too complicated. I mean, how are you going to make that informed decision? Lines of code, number of sprintf statements, reverse analysis. Who's going to make an informed decision on the best product? It's a specialized decision that needs to be made by experts, not a general market force. So the market failed us. People bought products based on number of features. They didn't buy them based on how secure they were. Well, that's okay. Doesn't matter if that didn't work. We've got some other options. So in the 2000s, we believed that insurance would save the day. That's okay. Insurance premiums will force companies to act more rationally. Insurance will make sure that companies buy secure products. They buy secure products, they have less problems, their insurance rates go down. Market forces will save us again. Except it didn't. The problem here is there's no standards for creating data. There's no national breach notification law. How do insurance companies collect statistics to build actuarial tables? Every report you read online has a different number on how much intellectual property has been stolen. Every report has a different statistic on how many times a company's been attacked. There's no good data. If you want to help the insurance companies, you need to help create good data. Otherwise, the insurance market is going to fail us. But that's okay, because now it's the 2100s or 2010s, and we've got governments that will regulate for us. The governments will save the day. The market couldn't save us, insurance companies couldn't save us, governments will save us. And this is a big question right now. Do governments even know what to do? And when I talk to governments, they're very reluctant. They don't want to harm innovation. They don't want to do anything to slow down technical advancement. And companies tell them, don't regulate us, we're Facebook, we're Microsoft, don't regulate us or else competition will be harmed. We won't be as quick. We won't create as many jobs. And because of that, very few things are regulated. Privacy regulations, networks. Do you even have to report if your network's broken into? So we're sort of in this period where governments aren't really doing it, markets aren't doing it, and insurance isn't doing it. That leaves us. I mean, It's really down to us now. And this is both exciting and depressing. When I think about it, is this the state we're really in? It's up to us to provide the leadership to decision makers. If governments are going to regulate, they're going to turn to experts like us to tell them what's possible and what's not possible. We need to be able to speak to them in terms they understand. And we need to help companies understand and do the right thing with their networks. Companies need to understand they're not an island in the sea. They're hyper-connected, and if they have bad network health, their neighbors around them will have bad network health. So I'm drawn to this analogy, going back to the medical public safety theme. First, do no harm. And sometimes it could be better to not do something or to do nothing at all than it is to do something and cause more harm than good. So think of that when you're working on your network. Sometimes it's maybe better not to do something. Maybe it's better to not roll out that risky new service without testing. So for me, I tried to interpret this. I have a couple of ideas. First, do no harm to the trust of the users. You need to be open about your policies. All right? You need to explain what the expectations are. When you're on my network, I'm going to monitor your behavior to make sure you're not infected. Okay. The users understand, and now understand the rules. If you never tell the users the rules, you're going to make them, they're going to be distrustful, and they're going to be resentful when you change the rules on them without telling them. You need to be honest about the risks of technology. And this is going to be difficult because you might need to speak truth to power. You might need to have to tell your boss, you know what, that's really risky. Are you willing to take that risk? But you need to be honest about the risks of new technologies. I'm not saying don't deploy new technologies. I'm just saying open your eyes. Make sure those on your team understand the risks and assume the risks. I don't care if you take risks. I get concerned if you take risks and you don't know you're doing it. And so don't let wishful thinking influence your decisions. I mean, we've all been to the doctor. They're pretty honest with you. They're not like, sure, no problem. No, they'll tell you every little risk that you could be facing, every drug interaction you may have. They want you to be a fully informed patient and understand the risks and the procedures. So, this has brought me to the thinking of community immunity. This also is a theory is called herd immunity. It's a theory used in vaccinating populations. And you get a certain amount of community immunity when a significant portion of the population has a measure of protection. So we're going to go through a couple of slides on this. So there's 3 modes of immunity, of community immunity. In the first mode, nobody is vaccinated. Nobody has any protection. And you can see over time, this is the worst situation you can be in. Almost the entire population becomes infected. In the second mode, we have some of the population, the yellow characters, are vaccinated. And you can see this reduces the transmission slightly in the population. So you get some benefit if some portion of your population is vaccinated. Now the third mode is the most important. This is most of the population is vaccinated. You can see between the two, once most of your population is vaccinated, even those that are not vaccinated get a benefit. So, and these are statistics. This will tell you how much of your population actually needs to be vaccinated for you to get a conferred immunity. So, when I was looking at this, I was thinking, does this apply in the internet? Does this apply in a networked world? How would I apply this? Okay, so here are 3 modes of immunity. And here's Jeff, the network security guy, thinking about the problem. What would I do? Well, in the first mode, networks and systems are not maintained. Malware spreads through the networks without notice. Nobody's monitoring anything. And there's little to stop the spread of these. Okay, that analogy works. There's probably a corollary there. The second one, some systems and networks are not maintained. Malware is sometimes noticed. It's probably noticed by big companies, companies with security teams, maybe some government agencies, academics. And the malware spreads through some of the population. And finally, where we would want to be is most networks and systems are maintained. Malware is noticed almost immediately. It's removed. Actions are taken to not only protect the network, but those networks around them. And this would be the conferred immunity stage in a network analogy. And right now, I think we're somewhere between 1 and 2. I think the movement is more toward 2, maybe 2 and a little bit of 3. I don't think we can ever get to the third mode without government regulation. And I hate saying that because I don't like government regulation. But after 20 years, there's a reason why we're not at 3. We haven't gotten to 3 in 20 years by ourselves. I bet you we're not going to get to 3 unless we have regulation. So that means that regulation is going to be very important. So that makes me think, right? Can a firewall act as a vaccination? Are there technical things we can do on our networks to sort of vaccinate ourselves and others? Or is this going to break down and it's not going to work? There's been a little bit of study in this area, but not much. There was a white paper called Internet Bad Neighborhoods that was really looking at the network to see if there were bad neighborhoods in the internet, not what happens if a good network is interconnected with a bad network. So I think if you're a researcher, there's a lot of unique work that could be done here. So if you want to be in the first group, the first mode, that's the non-immunized group, just don't do anything. Just sit back, have coffee. You don't go out of your way to monitor your systems. You don't do anything to protect your networks. You don't stay up on patches. And I generally think of this as the home user. Unless the system, operating system, OS X, or your antivirus program does something, nothing will get done. They're essentially a passive user of the network. And there's some advantages to this. It's really cheap. It's the least expensive option, and it requires the least amount of skill. It just happens. The problem is you're part of the problem. You're making the internet a worse place for others. And increasingly, there may be legal consequences. For example, in some countries, if you have a open Wi-Fi access hotspot without a password, and somebody uses your hotspot to commit a crime, you can be held partially liable. You were supposed to apply a password to your hotspot, and you didn't, and you made the internet worse. So as we look at regulation in the future, don't be surprised if this first option becomes more and more risky. You can't just claim, I didn't know. The second mode was the protect only yourself. I call this partially immunized. And what this means is you're only protecting your networks and your systems. You're not really doing anything to help anybody else. And examples would be things like you patch and update your systems, you stay on top of buying the best software. Right? You might filter spoofed traffic inbound to your networks. So you might filter like RFC 1918 address space, but you're not filtering on the outbound. You might enable DNSSEC validation on your name servers, so your users are getting good answers, but you don't sign your own zones. So others are not getting good answers from you. Only your users are getting good answers from others. You may check Sender Policy Framework, or SPF records, to try to limit the amount of spam your network is receiving. But on the other hand, you don't publish an SPF record to tell the rest of the world. Again, you're getting the benefit, but you're not helping others get a benefit. And the advantages here are, it's a lower cost than being fully immunized. The changes are not as complex as being fully immunized. And you're in a better posture. You're in a better position to protect your networks. But there's a higher management and configuration cost. Your administrators have to be more skillful. If you're doing this yourself at home, you just have to have more knowledge. And finally, we're in the fully immunized state here. This is like the ideal. This is where you go out of your way to help others. You don't have to, but you do. This would be a lot like the second one, but now you're also filtering outbound traffic. And this would be filtering something called BCP38 addresses, BCP84 address space, RFC 1918 addresses. If you look at how denial of service attacks happen on the net, a lot of it is through spoofed traffic. A large portion of harm on the internet can be reduced, it can be managed, if everybody was filtering spoofed traffic. You would DNSSEC sign your zone. You might disable recursion on your name server so people don't use it in amplification attacks. You would also make sure for your time server, not anybody can query maybe your time service, so your time server can't be used in an attack like we just saw last week. You can see the difference. You are doing things that are helping others. And this is where I believe the network gets a conferred immunity. Only in this third state does the network start getting better around you. It's the most beneficial to the largest number of people on the internet. It's the best security for yourself and others. But it's the most expensive, requires the most skill. And I don't think we're going to get here without regulation. But in the medical field, there's regulation. We still have a functioning medical system. Public health around the world's improving. Maybe there's something to be learned there. For example, if you look at DNSSEC around the world, here's a map of all the country codes in the world and whether or not they're ready to receive DNSSEC signed zones. And this was January of 2014. If you look at this map, the vast majority of all internet users on the planet can use DNSSEC. So we're in a chicken and an egg situation. The network is ready for DNSSEC, but nobody's really adopting it. Why is that? It's a chicken and the egg situation. For DNSSEC to be useful, people need to sign their zones. Nobody wants to sign their zones until they know it'll give them a benefit. So we're in a stalemate right now. And you see the same thing happening with IPv6. Why would I deploy IPv6 if nobody's using it? Well, pretty soon, there'll be parts of the world that will only be reachable over IPv6. And then market forces, will hopefully force people to upgrade their networks. So what if you don't own or operate a network? What if you're not a company with a big, or an ISP? Well, I'm not going to go into a lot of detail, but I just want to give you some ideas. Donate your resources. This is the idea of you donate blood to help others. Why don't you donate some internet resources? So I've got a couple examples. Let's say you want to help political activists, reporters, other people increase their privacy and security around the world? Well, you could donate some of your CPU and some of your bandwidth and run a Tor node. You could just set it to use a little bit of your bandwidth. Won't really impact your network. And you're making the overall internet a safer place for people to browse securely using Tor. Right? You could be part of the solution, and all you have to do is turn it on and update it once in a while. Maybe you want to help gather that data. Maybe you want to help instrument the internet and help everybody, not just researchers, understand the current state of the world, current state of the internet. Well, RIPE in Europe will give you what's called an Atlas probe for free. You plug this Atlas probe into your network at home or in your company, and now it's part of over 4,900 or 4,800 probes around the world measuring the internet. And academics can now go to RIPE and they can submit jobs. They could say, they can ask questions like, I wonder if I can spoof traffic out of Europe. I wonder how many countries are not reachable in China. I wonder if anybody's name server in Europe is telling lies. Well, now we can know. We can use the RIPE Atlas network and ask questions from anywhere on the planet. You can help out by plugging in a free probe and donating some bandwidth, right? You can help be a researcher, whether you understand it or not. Or maybe you really do want to help cure cancer. The Folding at Home Distributed Computing Project uses some of your bandwidth to help fold proteins through a simulation. And through folding proteins, new novel drugs and cures could possibly be discovered. So you're donating your CPU time. This is something that Sony did with the PlayStation 3. By default, they installed the Folding at Home project. So if you weren't playing games, you might be helping the planet. And these are just 3 quick examples. If you really want to help out, I'm sure this room of people can find ways to donate resources to make the world better. Now, my community immunity analogy breaks down a little bit. Because when we're talking about diseases, we're talking about one community, humans. But when we're talking about communities online, we're talking about different populations. We're talking about companies that behave differently than governments, that behave different than individuals. And so I think for my analogy to really work, I would have to look at each one of these populations, and I would have to say, if you were a company, what could you do? If you're a government, what could you do? And then I would start telling each population how they could make a difference, how they could get a conferred immunity, how they could help out. But so far, I'm really liking the direction of this. So finally, I want you to all think about the future. You're going to be listening to a lot of talks here that are very cutting edge, very technical, and they're going to be exposing vulnerabilities in a certain class of products or a certain piece of software. And I want you to think about the big picture, and I want you to think about the future. Part of the future is next generation technologies. For the first time in 20 years, the internet is essentially getting an upgrade. The way we used to use the internet and the way we're going to use the internet 10 years from now are different. If you look at the future, it's going to be Dnsec. Maybe not this year, maybe not next year, but within 4 or 5 years, we will be using Dnsec because it's safer. And it allows companies to build new products. So for example, Dnsec allows you to ask a question to DNS, and you get an answer back. And you can trust that answer. You can trust that IP address for the web server. But what if I ask DNS a different question? What if I'm not asking for the IP address of Google? What if I'm asking for a picture of a cat? What if I'm asking for a recipe? What if I'm asking for a digital certificate or a music file? For the first time, you will be able to ask a question and trust the answer. And I think that's going to enable a huge new class of products that we haven't even thought of yet. And once people start building those products and using Dnsec, the market will take over. The first killer app for Dnsec right now is considered Dane. And what you do with Dane is you publish your own SSL certificate. And so I signal to you with Dane, I say, you want to come to my website using SSL? Okay, only trust my website if it's this SSL certificate. If the fingerprint of the SSL certificate is in my DNS, then trust it. If the fingerprint doesn't match, then it's a man-in-the-middle attack, or somebody is faking my SSL certificate, or a certificate authority has been compromised. Well, in the future, you get trust agility. You get to change your SSL cert whenever you want, immediately. You don't have to count on a certificate authority. You control your destiny. And that's going to be done through Dane. And you already see mail servers, Postfix is supporting Dane. New web browsers, I think Chrome is supporting Dane. There's a plugin for Firefox. So several years from now, everything will speak Dane. And we will start to mitigate and manage the harm that can be done by rogue CAs. We're also going to move into an IPv6 world. Now, maybe not all that interesting to security researchers, but the one thing it does do is it helps us with attribution. One of the big problems with IPv4 right now is since we've run out of address space, we're sticking everything behind network address translation devices, or even worse, carrier-grade NATs. And it makes it almost impossible for law enforcement to figure out who really attacks you. It's a lot of looking through logs to figure it out. In the future, no more carrier-grade NATs, hopefully. It'll just be IPv6, which will help with better attribution. It'll give us unlimited growth, and it'll enable a whole new class of products that will re-inspire the Internet of Things. It'll re-inspire the marketplace for innovation. So the Internet is changing. 10 years from now, I hope to give this speech, and I hope to be able to say, you can send email securely. You can browse the web securely because of technologies such as Dane and Dnsec. So I want to leave you with this thought. And I want you to talk to me at the reception and later today. Has thinking about Internet security in a public health context been useful? Is it going to help you when you talk to your management? Is it going to help us as a community when we have to go and explain to governments and companies what we're trying to do? And I hope it helps us sleep better at night because we're not convincing ourselves we have to solve 100% of the problem. We have to cure cancer. No, we just have to work at curing cancer. So with that, I want to thank you very much and welcome you to Code Blue. Thank you. I'm not sure if we have, should I do questions? We're done with time? Nope. We're out of time. Okay, so I'm going to be around all day today and tomorrow, and I'm happy to talk to any one of you. Thank you very much.